we are, right? With the first question. The model and the actual ratio is 1 to 250. The height of the actual building is 212, and we are trying to figure out the model's height. We do cross product. We do 1 times 212, then divide by 250. We get 0.8. We get 0.8 as the answer. Let's go ahead, move on to question 3, and we are talking about 5.03 quiz, scale factor applications. This is again question 1, variety 2. The Eiffel Tower is about 301 meters tall. The Eiffel Tower is around 301 meters tall. Cooper is making a scale model of it using scale factor. Now, scale factor is 1 ratio 750. Let's see how we can express that. So, the model to the actual. This is also going to be the next unit after interim assessments we will be learning. And the scale factor is 1 to 750. We also know the Eiffel Tower is 301 meters tall. This is the actual height, right? The Eiffel Tower is 301 meters tall. 301 is the actual height of the Eiffel Tower. Goes here for actual. The question says to the nearest tenth of a meter means 1 decimal place. To the nearest tenth of a meter, so 1 decimal place. What will be the height of the scale model? You want the height of the Eiffel Tower in the model, in Cooper's model. Again, what you will do, remember numbers don't seem to be so compatible. Cross product is a good option. The question is allowing you to use calculator, so please use that. You will multiply first 1 times 301. Multiply 1 times 301, you get 301. And then you will divide. You divide by 750 to figure out how much is the height of Eiffel Tower in Cooper's model. Go work out the problem. Tell me how much do you get. 301 divide by 750. How much do you guys get? Very good, Sean. This is what I got approximately. I also got 0.4. To the nearest tenth means 1 decimal, so I got 0.4. So we can say here the model's height is going to be 0.4. Nina, I'm going to publish recordings after this session, and you will be watching recordings from the session, and this way you'll catch up with what we learned in class. Right, Nina? Third variety of question 1. Here's the third variety of question 1. The question says, there's another name of a tall building in Dubai. Says Burj Khalifa. A building in Dubai, United Arab Emirates, is 282 meters tall. It is a tall one, right? 282 meters tall. Birdie is making a scale model of this building using a scale factor of 1 ratio 500. So let's see how we express the scale factor. And we will say in this particular question, the scale factor is 1 ratio 500. Oh, let me see and fix this one. I should say model to actual. This is the kind of scale factors we'll be writing. So in the model, I will represent 1 unit to show 500 actual units. The model uses 1 unit to represent 500 actual units because models gotta be smaller and manageable, right? Now the bridge itself is 828 meters. This is the actual height. 828 is the actual height of this really tall building. You will have to figure out how much is going to be the height of Birdie's model if he uses the ratio of 1 to 500 so that he can create a model for this building. Again, notice the numbers are not compatible. We can do cross product. Multiply 1 times 828. 1 times 828. That gives you 828. And then divide by 500. Honestly, dividing by 500 will not be a hard task if you really did not want to use a calculator. Right? Dividing by 500 should not be a harder task. Then divide by 500. This is another way to find for missing proportions. Go do the calculation. Tell me how much do you get. 828 divide by 500. 0.6. No, it's not going to be 0.6, Sean. Oh, Sean, we didn't set it up right. Sean, see, 828 divided by 500. You did it the other way, Sean. 828 divided by 500. The answer is going to be 1 point something. And then the answer is going to be 1 point something. Right? And when I did this one, I got an answer that was around 1.7. Because at least 1/500 will go into 828. So the answer was actually 1.7. Right, Sean? There you go. I see you fixed it. So the answer is going to be approximately 1.7, closest to the nearest tenth. There was little to no confusion with question 1. And then question 2 is also very similar. And there is very little, tricky part in question 2. So let's see how question 2 looks like. Question 2. The actual distance between two villages is 120 kilometers. This is actual. On a map of the area, the map says this. Map says 0.5 centimeter represents 2 kilometers. This is a map. Let's see how I can write this out. So map says 0.5 centimeters are to represent an actual distance of 2 kilometers. Right? This is what the question told you. The map represents 0.5 centimeters to represent 2 kilometers in real. They also gave you that the actual distance between two villages is going to be 120 kilometers. Where do you think you will place 120? Where do you think? Jasmine, welcome to class. Macy, welcome to class. Join your pod. Davin, join your pod. And this way I'm going to be able to see your work and I'm going to be able to give you feedback. So the actual distance of this village is 120 kilometers. So 120 goes here. Notice that the numbers were very compatible. The numbers were very compatible. and you can figure out the answer. From 2 to 120, it is how many times? From 2 to 120, it is how many times? It's not going to be a very hard one. Bella, Sean, Nina, Jasmine, Macy, Bella, Trey, think about it. From 2 to 120, it is going to be 60 times. Very good, Sean. It's going to be 60 times. So I'm going to say times 60. And I'm going to also do the same operation over here to figure out the missing value. I'm going to do 0.5 times 60. 0.5 times 60 means to find half of 60. 0.5 means half. So 0.5 times 60 means to find half of 60. And half of 60 is going to be 30. So my answer is going to be 30. So my answer is going to be 30. What is the distance between the village on map? The distance between the villages on map is going to be 30 centimeters. Let's go ahead, move on to second variety of question 2. And here it is. On a map, the distance between two historical markers is 4.5 inches. And they also tell you about the scale. And 2.5 inches will represent 10 miles on a map. So what is the actual distance between the historical markers? Let's see, what do we know in the question? They're talking about a map and they're talking about actual. And what they're saying is that 2.5 inches will represent 10 miles. So let's do that. So 2.5 inches on the map will represent 10 miles in actual. That's how you set it up. That is given. That 2.5 inches will represent 10 miles. On a map, now again, more information given to you about the map. It says on the map, the distance between two historical markers is 4.5 inches. So again, go up to the map and the distance between the two historical markers is 4.5 inches. What is the actual distance? What is the actual distance means question mark goes here. What is the actual distance between the historical markers? Sean, 4.5 is on the map, so goes at the top. Sean, see, on the map, the distance between the two historical markers is 4.5 inches. And remember, inches is at the top for map, and it also says it's on the map, so it's going to be at the top. Again, in this one, I was thinking Guyana. Guyana. I am going to note your name, Guyana. We will talk about this one at a personal level, Guyana. Expect me to give you a call today. Okay, Guyana? I will definitely give you a call and we will talk about it. Right? Absolutely. So let's see. One easy way to resolve this problem is to do, oh, I'm not hitting the right part. Do cross product. Multiply the two cross numbers, right? 4.5 times 10. Multiply them. 4.5 times 10. See? They are make a x. They kind of make diagonal. You can multiply them. So 4.5 times 10 gives you 45. 4.5 times 10 gives you 45. Next, you will do division. You will divide by 2.5. Right? Then divide this 45 by 2.5. Go do the division by 2.5. Everybody work it out. Do 45 divided by 2.5. Nina, I agree to you. I also got 18. There are also a lot of good mental math strategies that could be applied here to get the 18 without doing some long division. So this actual distance between the historical markers is going to be 18 miles. The actual distance between the historical markers is going to be 18 miles. Let's go look at the third variety of question 2. Well, my Nearpod did not refresh. Let's see. Hopefully it will. Yes, it did. So now on a map, the distance between two towns is 2.5 inches. Again, read the keyword. It says on a map. The distance between two towns is 2.5 inches. Now they also tell you about the map. They're saying 1 inch represents 6 miles. This is the information I will start with. Map to actual. And they say the map to actual, 1 inch represents 6 miles. So I'm going to say, okay, and 1 inch represents 6 miles. This is the connection. This is the scale factor, right? Then on a map, the distance between two towns is 2.5 inches. And it is also in inches. So where do you think 2.5 will go? Will it go in the numerator or the denominator? On the map, the distance between two towns is 2.5 inches. Where will 2.5 go? Sean, it is in inches, right? 2.5 inches. Nina, on top, Nina, you are right. Nina, how do you know it goes at the top?
Because it's a decimal.
Because it says the word inches. 2.5 inches, right, Nina? And this one is also inches at the top. Also, it says on a map. And map is the one I'm trying to put at the top. So therefore, I got to line up the numbers, right? This one was a very simple one. Notice it was just multiplicative. From 1 to 2.5, we can multiply by 2.5, right? Because from 1 to a number, it is very simple to get. Just multiply by that number. Same for denominator, from 6 to this missing number, you should multiply by 2.5. 6 times 2.5. Go do 6 times 2.5. How much do you guys get? 6 times 2, and then add another half of 6. 15. Yeah, 15 is the right answer. And that is going to be 15 miles. 15 is the correct answer. So what is the actual distance between the two towns? The actual distance between the two towns is going to be 15 miles. Let's go ahead, move on to question 3. And I noticed that question 3 was a nice question. Question 3 has a lot of thought in it. And when I was planning to teach you, I was thinking, okay, how I'm going to go about so that it will make the most sense. So I'm going to try my best And if you guys still have questions, feel free to let me know. It's just a little bit multi-step. And makes you think deeper. There should always be a question or two in the quizzes that should make you think deeper. It is a good thing. It is healthy. A town is designing a rectangular park that will be 600 feet by 1,000 feet. A rectangular area of the park for swing sets will be, so this is the swings. The swings will be 25 feet by 100 feet. On the scale drawing of the park, the swing set area is, and now they tell you about the scale. In the scale, in the small model, the same swing set area is 0.5 inch by 2 inches. So they gave you some information about the swing set. They are going to ask you, then what will be the dimensions of this park on the scale? Let's see how we can work this one out. So we talk about the swing. The swing, for example, swing's length and swings width is given, right? So first, we know that it is a 25 by 100. It is a 25 by 100, right? The swing part. Oh, we are back in the main room.
Yes, Miss Syed, I'm sorry. I just got a family emergency call, so I went ahead and ended it a minute and a half early. I apologize.
Oh, no problem. No problem.
They keep calling me with a 911 message, so I need to call them. But
okay.
We're done in our room. We just finished the GIM kit like 2 minutes ago.
Absolutely, Miss Smith. You are good to go.
All right. Thank you, ma'am.
I hope everything is safe on her end. Those of you who are here and here for math, we will continue with this question. I thought we had a couple of minutes, so I was a little bit shocked with the breakout room finishing up, but that's okay. So we were looking at the swing, right? The swing's length is 25 feet by 100 feet. So we can say, okay, it is 25 feet by 100 feet. This is the swing's length given to us, the actual one. And when you look at the model was 0.5 inch by 2 inches, right? So we can set it up. The model is 0.5 inch to 2 inches. So we want to see what are they trying to do. Absolutely, Xavier. The reading people can leave if you are good with the quiz and don't need help with my quiz. Reading people, you are good to go. You should not be sticking just forcefully. Absolutely not. So the important part here was we had to figure out, okay, to figure out from actual to the map. From actual to the map, what are we doing? Right, from 25 to 0.5, the number got smaller. It was dividing. Dividing by what? 25 divided by what was giving you 0.5? Anybody? From 25 to 0.5, I was dividing by 50. I was dividing by 50, right? Same here. When I divided 100 by 50, I got the scale drawing. The scale drawing was 2. Now we will use the same operation to convert the dimensions of the park to scale drawings, right? So let's see. Now it is going to be the park. So I can say park's length to park's width.
Miss, I have to go. I have another
Absolutely.
class.
Absolutely. Caitlin, nobody's forced to stay. This is a recorded session and I also publish the recordings. Now when we look at the park is 600 by 1,000. So we can say, okay, park is going to be 600 units to 1,000 units, length to width, right? 600 to 1,000. in order for you to figure out the scale measurements, we can refer to what we did over here. The scale measurements are missing, right? We will do this, what we did over here. We can divide by 50 because we know this is the standard they're using to figure out the scale measurements. They're dividing by 50 to figure out the scale measurements. And therefore, this is what I can do. So I can divide 600 by 50. It will tell me, okay, then on the model, it is going to be this much. And then I can also divide the width by 50. It will tell me how much it is going to be. Work it out, students, and tell me how much do you get. The scale drawing is going to be how much? The park's length by the park's width. When I do 600 divided by 50, I get an answer that is going to be 12. So I know one of the dimensions is going to be 12. When I divide 1000 by 50, I get an answer that is 20. So I know the measurements on the map is going to be 12 by 20. Are there any questions before we end the session, Nina? Yes. So this was a little bit of multi-step. I was looking at the complete information for swing. Then I applied that to the park. This question 3 was the only one I was thinking would be a little bit more steps, might confuse some of you. So it was a 12 by 20 park. This does mark the end of the session. We will look at the rest of the 2 varieties of question 3 tomorrow. If you have further questions, feel free to ask me, email me, and I am here to help. I'm going to publish recordings for all the sessions by now. I'm also going to respond back to emails at this time. So feel free to approach. Gianna, I am going to definitely contact you. So be ready. Everybody, thank you so much for joining.